Okay, let's go ahead and do this review sheet for the midterm for the Algebra 1 class. So let's start over here with number 2. Folks, you can't do anything without distributing. So the first thing we need to do is take this 2 and take this 1/2 and distribute it to what's in the parentheses. Now what I like to do is take what's out in front, make a complete circle including its sign, and then do the same thing with the first term. So we're going to have 2 times 4n, which is going to be 8n. We're then going to do the same thing with this -6. We're going to put a circle around it. We're going to take the 2 and multiply it by -6, and that's going to get us -12. On the opposite side, we're going to do the same thing. We're going to take the 1/2, we're going to circle the 16n in our mind, and we're going to multiply them. So if you want to do it on the side here, we can have 1/2 times 16n, and feel free to put a 1 under the 16n to make things easier for yourself. So now we have 16n over 2, because recall, when we are multiplying fractions, we are allowed to multiply straight across. We do not have to have a common denominator here. So now we have 16n over 2. Now we can break 16 into 2 times 8 over 2 and then cross out the 2's. So we're going to have 8n as a result of multiplying the 1/2 times the 16n. Okay, next we are going to take that 1/2 and we are now going to multiply it by the -24. Again, I think it's helpful to put a circle around that. So we're going to do a very similar thing. We're going to multiply straight across, and we're going to have -24 over 2. We can now break this -24 into 12 times 2 over 2, and that gives us a -12. Immediately, folks, we see a true statement here. It is always going to be true that 8n minus 12 equals 8n minus 12. So we don't need to go any further than this. We know that this is going to be all solutions, or infinite solutions. Okay, let's now move on to the next problem. Let's go to number 4. Okay, the first thing I see is a variable and a constant on one side and a variable and a constant on the other. Recall, constant is just another name for a whole number like that. That's never going to change. Okay, this term is going to change predicated on what the r value is, but that's a constant. Okay, so whenever you have constants and variables together on one side, the goal is to get all variable and all constant on one side of the equation. Now it doesn't matter which is which. So you can have v for variable here and c for constant on that side, or you can have the opposite. You can have all the constants here and all the variables here. But this is the intuition of how to approach this. All right, let's take a look at our problem at hand and see what we have. Okay. To me, the easiest thing at this point would be to take this -8r and move it to the other side of the equation. So it looks like I'm going to end up having r's on this side and then constants on the other side. So I'm going to take this -8r and I'm going to move it to the opposite side of the equal sign. And when we do that, we change the sign of the -8r to +8r. So now we are now going to have the original 8r, which was there initially, right? This was the initial 8r plus 30, and now we have plus 8r that we brought over from the other side. That is this one right here. So now we're going to have, we can combine these because we have like terms. So now we have 16r plus 30 equals minus 2. Over here, here's our schematic. We're having the r's on one side. We're going to get the constants on the other. How do we do that? We take this positive 30, we move it to the other side of the equation, and when we do that, we change the sign. So this becomes a negative 30. So now we're going to have 16r equals minus 2 minus 30. We are now going to go ahead and combine these terms. Easiest way to do that, I think, is to go to the number line. Okay, there's a 0 just to get oriented. We are starting at negative 2. Okay, there's our negative 2. This negative sign means we're going to be going to the left, and we're going to go 30 units to the left. So if we start at negative 2 and we go 30 units this way, we are going to be at negative 32. So we now have, let me change the color, we now have 16r equals negative 32. We have not yet solved for r because we have a neighbor. We're going to divide both sides by 16. And we're going to get r equals negative 2. Right there. Okay, folks, I realize that this might be new to you, this concept of taking that plus 30, moving it to the other side, and changing the sign. But as you'll see in a moment, it's no different than doing what you have been doing previously. So let's review what you had done previously, perhaps. If we wanted to get all the r's on this side and all the constants on this side, meaning all the numbers, one of the first things you might do is add 8r to both sides. That nullifies that, and then you have plus 8r. Well, folks, that's no different than taking this negative 8r, moving it to the other side of the equal sign, and flipping the sign. So those two maneuvers are one and the same. I'll leave it up to you what you find easier to do. I know sometimes change is hard, but oftentimes it'll result in a better technique. Okay, here's our next problem, number 6. Similar situation. We cannot solve this until we distribute. How do we distribute? We take the entire number, including its sign, we put a circle around the first term, and we multiply the 2. 2 times 3x is going to give us 6x. We now do the same thing with the second term, including the sign. 2 times positive 9 is going to give us positive 18, and we now have that equal to negative 12. We have a variable and a constant on this side. We have a constant, meaning a regular number over here. The goal here is to take this positive 18 and move it to the other side. What do? We put a box around it and its sign. We move it to the opposite side of the equal sign, and it now becomes negative 18. So now we're going to have 6x equals negative 12 minus 18. These are like terms. We can go ahead and simplify that. Number line. Start at 0. Well, I should say, place a 0 to give you perspective. We're going to start at negative 12. This negative sign means we're going to move to the left. How far we're going to go? We're going to go 18 spots. So if you start at negative 12 and you march 10 spots, you would be at negative 22. If you march 18 spots this way, you're going to be at negative 30. So now we have, let's change colors. Now we have 6x equals negative 30 We divide both sides by 6, and our final answer is going to be x equals -5. Let's move on now to number 7 over here on this side. Okay, folks, can't do anything until you distribute. We take a circle. We go around the number and the sign. We take the first term and we do the same thing. We take -2 times 3b. Whenever you multiply a positive and a negative, you get a negative. We're now going to do the same thing with the -2 times +2. That's going to give us -4. Let's write down the rest of what we have. Okay, now let's assess what we have going on here. We have a variable, there's the b. We have constants over here, and we have a constant over here. So our goal, here's the schematic. We're going to get the variable, which in this case is the b. Okay, I'm going to change colors. We're going to get b on the left, and we're going to get all the constants on the right. That is our schematic. Now notice, we can combine these to make our life easier. Okay, if we have -4 plus 22, we can combine those. Those are like terms, they're both constants. So let's do it. Here's our number line. There's our 0 to get oriented. We're going to start at -4. This plus sign means we're going to go to the right 22 units. Okay, so if that total line is 22, the entire length of that blue line is 22. We're going to use up 4 to get back to 0 right there. That means there's 18 left in the positive zone. So we're going to end up at positive 18. So I'm going to go ahead and rewrite this as -6b plus 18 equals -12. All right, keeping in mind our schematic up top, we want to get all the constants, all the numbers on the right side. The schematic is up here in blue, right here. Okay, we're going to take this positive 18. We're going to put a box around the number and the sign. We're going to move it to the opposite side of the equation, and in doing so, we're going to change the sign to -18. That's going to give us -6b equals -12 minus 18. We can combine these. These are like terms. Excuse me. Let's go to the number line. Give us a 0 to get oriented. Put a circle around that. We're going to start at -12. This negative sign means we're going to be going left. How far left? 18 units left, because this is 18. Okay, where does that put us? Well, if we take 18 and we go left, if we went 10 units, we would be at -22. We're going to go another 8 units, and we're going to end up at -30. So we're now going to have -6b equals -30. We are not done yet, because b is not by itself. It has a neighbor, namely -6. So what do we do in that case? Because there's multiplication going on, we divide. What do we divide by? We divide by the neighbor. Exactly what you see here is what we divide by. That allows us to cancel these. We have to do the same exact thing on the opposite side, including the sign. We now have a -30 being divided by -6. That means our answer is going to be positive. If we break down 30 into 6 times 5, the 6's cancel out, and our final answer is +5. see where we are now. Let's go to number 8. Okay, number 8, same thing. Distribute, combine like terms, and solve for x. We'll take a circle, put it around what's out here. Same thing here. We're going to multiply 3/4 times x, or 3/4 times x over 1. When we do that, keeping in mind that with fractions you can multiply straight across, we're going to end up with 3x over 4. Next, we're going to take that fraction. We're going to multiply it by the second term, including its sign. So we're going to have 3/4 times 12 over 1. When we have fractions and we're multiplying, we can multiply straight across. We do not have to get a common denominator. Now, what I'm going to do here is I'm going to leave everything the way they are. Okay, I don't need to put the 1 there. Now I'm going to take that 12 and I'm going to break that down. Okay, so we're going to have our original 3 here, our original 4 down below, and I'm going to take this 12 and I'm going to break that down into 4 times 3. When I do that, that allows me to cancel the 4's. I'm left with 3 times 3 equals 9. So now we're going to have 3/4 x plus 9. And let me clean things up a little bit. Appreciate your patience. Okay, so we are done distributing. We're done with those arrows. We're going to simply rewrite this plus 8 over here. And we're going to rewrite the 17. Okay, so folks, how do we handle this? How do we handle this? Well, we have a fraction here. But we also have 2 constants here that we could combine. In math, if you're not sure what to do what you know you can do. You know you can combine these. So let's do that. So now we're going to have 3/4 x, or 3x over 4, plus 17 equals 17. Okay, again, you may not be sure what to do here. You have a fraction, you have x over here, but what do you know? You know that the goal in these problems is to get the variable on one side, which in this case is the x, and the constants on the other. You know that is your schematic. So what we're going to do is we're going to take this constant. Remember, the number constant is another word for just a number. We're going to take this positive 17 and we're going to move it to the opposite side of the equation. And when we do that, we change the sign. So now we're going to have 3x over 4 equals 17 minus 17, which is 0. Okay, how do we handle this? Well, intuitively, we can say to ourselves, the only way to get 0 is if that x is 0. But if you're not sure, this is how we can handle this. We could change this to a fraction, 0 over 1. We now have 2 fractions facing each other with an equal sign. Whenever you have this construct, a fraction equal to another fraction, we are allowed to do something very powerful in math called cross multiply. And if you can become an expert at cross multiplication, you can solve any problem, basically. Cross multiplication involves this times that, which would be 4 times 0, equals, don't forget that equal sign, this times that. with an equal sign. Cross multiplication. We're multiplying and we're creating a crisscross. 4 times 0 is 0. 1 times 3x is 3x. Still not done because we have a neighbor next to x. At this point, we're going to divide both sides by 3, and we're going to end up with x equals 0. Okay, let's move on. See if there's any more to do. Okay, let's take a break here. Continuing on with the Algebra 1 midterm review, we are now on problem 9, and we are introduced to absolute values. Now, absolute values present some unique challenges, but nothing that we can't handle just using basic algebra techniques. Okay. The key to absolute value problems is you have to get the absolute value by itself on one side. I abbreviate it with ABS, and then you have to have everything else on the opposite side. You can't do anything until the absolute value is by itself. So you can see here, that's what the student did. The student isolated the absolute value by itself. So what the student did here was take this -2, move it to the opposite side of the equation, opposite side of the equal sign, and change it to +2. That left us with absolute value of y plus 7, perfect, it's now by itself, and then we had -5 plus 2. So if we go to the number line, put 0 down there as a reference point. First we start at -5, that's right there. This plus sign tells us we are going to the right. How far? We're going to go 2 units to the right. And that's going to put us at -3. That's how this -3 was obtained. Now, you could see the answer to this problem was no solution. And here's why. Whenever you have an absolute value, whatever the stuff that's in there, even if it's initially negative, the absolute value changes it to a positive. So there's nothing that can emerge from an absolute value and give you a negative answer. So that's why there is no solution. Okay, let's move on and come to number 10. Okay. The goal with any absolute value problem is to get this schematic. Absolute value by itself, everything else on the other side. And by absolute value, I mean this construct right there. So we need to isolate that by itself before we can do anything. So what's preventing us from this being by itself? This -3. So I'm going to take that -3 and move it to the opposite side of the equal sign. When I do that, I change the sign. It becomes a +3. We now have the absolute value of 2n minus 8 equals 0. Okay, so far so good. We can have absolute value equals 0. We just can't have it equal to a negative. Okay, what do we do here, folks? All right. I mentioned that absolute values present unique challenges. And here it is. It turns out that once you get the absolute value by itself, which we've done, you set whatever's inside the stuff, you set this stuff equal to what's over here, okay, so far so good, and In addition, okay, I'm going to put a line here. In addition, you set up a totally separate equation where the stuff inside the absolute value sign is equal to the opposite side times -1. In this case, -1 times 0 is just 0, so it doesn't matter. But as we'll see going forward, it's gonna matter with most of these problems. So let's review. Whenever you see an absolute value problem, the first goal is to get this construction, absolute value by itself, equal to stuff on the other side. Okay? That's what we did. We took this -3, we moved it to the opposite side, and we combined and we got 0. Next, you set whatever is inside the absolute value equal to what you have on the other side. Okay, that's part 1. Part 1. And then you put a line here and you do part 2. Part 2 is going to be setting whatever's within the absolute value sign equal to what's on the opposite side times -1. And now you solve both of these. Sometimes absolute values problems have one solution. Sometimes there's two, and sometimes there's no solution. So here we go. How would we solve this? Folks, we know how to do this. The goal is to isolate n. We have a neighbor here. We got to get rid of that first. It's easier to get rid of this neighbor than the 2. The 2 is bounded tight to the n. Think of it that way. It's easier to get rid of that -8. How do we get rid of that -8? Two ways. We can add 8 to both sides. That's fine. And that'll give us 2n equals +8. Then we divide both sides by 2. And we get n equals +4. Or we could take this -8. Sorry. We could put a box around it, including its sign. We can move it to the opposite side and change the sign when we do that. So it gets eliminated from the left side and it becomes a +8. Two ways to do that. You get the same answer. Do the same thing over here. It's the same exact equation. We're going to get n equals +4. Okay. Last challenge with absolute value. You never just put this down and move on to the next problem. Unfortunately, you have to check your answer or answers with absolute value problems. So you have to take whatever answer or answers you get. In this case, we only have one answer. And you have to plug that back into the original equation and make sure that it's correct. So let's do that. Okay, the only answer we got is n equals 4. So you're going to take the absolute value of 2 times 4 minus 8. Okay, all I did was plug 4 in for n and then rewrite it down here. Okay, absolute value -3 equals -3. 2 times 4, okay, we're going to use PEMDAS here because we're multiplying 2 times 4. We're going to do that first. 2 times 4 is 8, minus 8, minus 3 equals -3. 8 minus 8 is 0. The absolute value of 0 is 0. I'm just going to cross it out, and you end up with -3 minus 3 equals -3. That's a true statement. That means we have a correct solution. Let's move on to the next one. Okay, number 11. first goal with absolute value problems is to get the absolute value by itself equal to stuff on the other side. That means we have to isolate this by itself. Okay, not including the negative 10, just the brackets. Okay, we have to have absolute value equals something else on the opposite side. Okay, so what's preventing us from having that construct that we want? This is what we want, this is what we have. What's preventing that? Us from having what we want. Okay, we want this by itself. Okay, what's preventing us from having that? Well, let's start with this. We're going to move this to the other side, and we're going to change it to -5. Whenever we move something to the opposite side of the equal sign, we flip the sign. Okay? So now we're going to have -10 times the absolute value of 3v plus 6 equals -85 minus 5. Okay? We are not there yet. We are not there yet because the absolute value construct is not by itself. It has this neighbor. Now, before we address the -10, which again is being multiplied by the absolute value, I want to simplify that. It'll make our lives easier. So let's go to the number line. Always put 0 to orient yourself. We're going to start at -85. This negative sign tells us we're moving in this direction, to the left. How far to the left are we going to go? 5 units. So if we start at -85 and we go 5 more units in the negative direction, we're going to be at -90. Okay, so now folks, we have -10 times the absolute value construct equals -90. I am not going to lie to you, these problems are very involved. Multiple steps, but nothing we can't handle. Okay, so what do we do here? We have -10, which we don't want here, being multiplied by this construct. Whenever we have a neighbor being multiplied by something we're trying to isolate, we divide by that neighbor, the exact neighbor. If there's -10 up here, it has to be -10 here. That allows us to cancel those out, but we have to do the same thing on the opposite side. A negative over a negative is going to give us a positive. We can cross off those zeros at the end, and we end up with +9 over here. Okay, so now we've done our job. We now have an absolute value by itself. Okay, we now have absolute value of 3v plus 6 by itself equals +9. Beautiful. Okay, we are not done. In this scenario, where you have absolute value construct by itself equal to stuff on the other side, we're going to create 2 equations. First, we're going to take this, what's right inside, and we're going to set it equal to what we see. That's equation number 1. So we're going to set 3v plus 6 equal to +9. Then we're going to put a line down here. I want you to remember this line. We have a totally separate situation over here. Totally separate. This time, we're going to take the stuff that's inside the parentheses and we're going to set it equal to the other side, which is +9, times -1. That's going to give us 3v plus 6 equals negative 9. So we're going to have two equations to solve. So let's do that. And then don't forget at the end, we're going to have to check both answers. These are very labor-intensive problems, but nothing we can't handle. Okay, so here we go, folks. We're trying to solve for v. Is v by itself? The answer is no. It has two neighbors. One, the 3 is multiplied by the v. It's in tight. The other one is plus 6. This is easier to get rid of first. How do we get rid of that? To me, the easiest thing to do is to put a box around it and its sign, move it to the other side of the equation, and change the sign. So that's going to give us 3v equals 9 minus 6. We can then combine those because they're constants. We have 3v equals 3. And if we divide both sides by 3, getting rid of that neighbor, we get v equals positive 1. On the other side, we're going to take this negative 6. This positive 6. We are going to move it to the opposite side of the equation and make it a negative 6. That's going to leave us with 3v equals minus 9 minus 6. Number line. 0 for reference. Start at negative 9. This minus sign tells us we're going to go left. How far left? 6 units. So if we start at negative 9 and we go 6 units to the left, we're going to be at negative 15. So we're going to have, on this side, we're going to have 3v. Let's clean this up. I'm going to take away everything but the negative 15. Okay. 3v equals negative 15. Not done yet. We have to get rid of that neighbor. That neighbor is being multiplied by v, therefore we divide. V equals minus 15 over 3. We have a negative divided by a positive, therefore our final answer is going to be negative. What is that answer? I'm going to break 15 into 5 times 3. Divide it by 3, we cross out the 3's, and we get 5. Negative 5. These are our two answers. Whenever we have an absolute value problem, unfortunately, we have to check both of these answers. How do we do that? We take v equals positive 1 and we plug it into the original equation. Let's do that. If v equals positive 1, what do we have? We have negative 10 times the absolute value of 3v, but we're going to put positive 1 in there. Negative 10 times the absolute value of 3 times 1, which is 3, plus 6 is 9, plus 5 equals negative 85. We take the absolute value of 9, that's positive 9, so we have negative 10 times 9, plus 5 equals negative 85. Negative 90 plus 5 equals negative 85. That is a true statement. Therefore, because negative 90 plus 5 is negative 85, so we're going to end up with negative 85 equals negative 85. That is a true statement. Therefore, this is a valid solution. Okay, we're going to do the same thing with the other one. Okay, v equals negative 5. Okay. We're going to take v equals negative 5, and we're going to plug that back into the original equation. My mistake here. Not this one, the original equation. Up in here. And let's see what happens when we do that. Okay, let's get rid of that v equals positive 1, put it here. We know that's one of our solutions. Now we're trying to see if this is going to be one of ours. Okay, sorry for all that house cleaning. Okay, so now we're going to have negative 10 equals the absolute value of 3 times negative 5 plus 6 plus 5 equals negative 85. Negative 10 times negative 15 plus 6 plus 5 equals negative 85. Negative 10 times negative 9 absolute value plus 5 equals negative 85. The absolute value of negative 9 is positive 9. That's going to emerge. We're going to have negative 10 times positive 9 plus 5. That's going to equal negative 90 plus 5 equals negative 85 equals negative 85. That means this is also a valid solution. So we have two solutions, v equals positive 1 and v equals negative 5 for number 11. We are now moving to the next section, which involves solving literal equations. So the word literal actually means letter. Like if you're going to follow someone's instructions literally, it means you're going to follow them to the letter. So basically, they're going to present you with which letter to solve for. That means we have to get this capital B all by itself. If we want to get capital B all by itself, it means we have to get rid of its neighbors. What are its neighbors? Its neighbors are h and the 1/3. So let's do that systematically. Okay. The first thing I see here is I don't like this fraction. So if we're trying to get rid of this fraction, we can do the following. We could say, okay, what is 1/3 times b times h? So what I'm going to do is I'm going to change this to 1/3 times bh over 1. Okay, the v stays the same. Now we are multiplying two fractions. Whenever you are multiplying two fractions, you are allowed to multiply straight across. We do not need a common denominator here. So now we have bh on the top, and 3 on the bottom. So folks, all we did here was multiply straight across. So now I have v equals bh over 3. Now you may say to yourself, well, how did that help? We still have neighbors bunched in. Okay, here's my next move. I'm going to change v to v over 1. Now we have two fractions facing each other with an equal sign in between. And whenever we are fortunate enough to have that scenario, we are allowed to cross multiply. To cross multiply, we're going to have first 3 times v, which is 3v. Don't forget your equal sign. 1 times BH is BH. Okay, now look what we have. Here's our B we're trying to isolate. It only has one neighbor. That neighbor is H, and it is being multiplied by H. We can now divide by this neighbor, both sides. And that gives us B is equal to 3V over H. And that is your final answer because you have solved for B. B is all by itself. So folks, here's the key move. The key move is creating fractions. Understanding that this 1/3 times BH can be written as 1/3 times BH over 1. Then, turning that into a fraction, turning this V into a fraction, V over 1, and then from here, cross multiplying. So that's the intuition of how to solve these problems. When you see fractions, don't hesitate. When you see 1/3 times something, don't hesitate to put that BH over 1. Okay, let's see what happens with number 16 here. Okay. Solve for y. Literal equation, letter. They want us to solve for y. So we want to get y by itself. So immediately, I see a similar scenario. I see a fraction being multiplied by the variable that we want to isolate. Just like over here. See the 1/3 times the capital B? We're going to do something similar over here. Okay. First thing I would do here is I would take this 4 and move it to the other side of the equation. Currently, that 4 is a positive 4. I'm going to take it, I'm going to move it to the other side of the equal sign, and I'm going to change it to -4. So that's going to leave me -2/3 y equals 10 minus 6x minus 4. Now, do you see anything here you can combine? The answer is yes. We can combine this 10 and that -4. So if I rewrite this as 10 minus 4 minus 6x, it's clear that's the same as 6 minus 6x. Okay? So I'm going to take this and move it here. All right. Now, folks, we're going to use the same trick that we used on the previous problem. I'm going to take this -2/3 times y, and I'm going to change this y to y over 1. Then I'm going to multiply straight across here. Multiplying fractions, you do not need a common denominator. So this is going to become -2y over 3 equals 6 minus 6x over 1. Because I'm allowed to change that into a fraction over 1. You could put anything over 1. We put that y over 1. You can put this expression over 1. Okay, now what do we have, folks? We have two fractions facing each other with an equal sign. That is a license to cross multiply. This is a little trickier, but nothing we can't handle. Let's get rid of this. And cross multiply here. So I'm going to take this 3 and I'm going to multiply it by what I see over here. Put parentheses around that. So I'm going to have 3 times 6 minus 6x equals, and then I'm going to multiply these two things, negative 2y. Now, I'm almost done. This negative 2 is preventing me from solving for y. I'm going to divide by this. And my final answer is going to be y equals all of this on the left side. Now, it's usually inappropriate to have a negative sign in the denominator. So in this case, your teacher might want you to rewrite this as negative 3, 6 minus 6x over 2 equals y. And there's your answer. So this negative sign, you're allowed to bring that up top. Okay, let's move on now to the solving and graphing inequalities. Folks, the key to solving inequalities, when they say solve, that means they want this variable by itself. Inequality means we are not dealing with an equal sign. This is not an equal sign. It has an equal in it, but it's technically not an equal sign. So the way we handle these, the unique thing about these is that when you multiply or divide by a negative number in your pursuit to isolate the variable, you have to flip that sign. So let's proceed. Other than that, you treat it the same way. So whenever you see an inequality, you look for situations where you are multiplying or dividing by a negative. And if so, you flip the sign. Okay. So we're trying to solve for u. What's preventing us from doing that? We have two neighbors. We have one in tight with the u, that's the 3, and then we have the one further separated. So I'm going to take this negative 7, I'm going to move it to the opposite side, and I'm going to change the sign. So I'm going to have 3u is less than or equal to 14 plus 7. Is there any reason to flip the sign there? No. We didn't divide or multiply. Basically, we added 7 to both sides. So in other words, what we did here was, to get rid of that negative 7, we added positive 7 to both sides. And that gave us 3u is less than or equal to 21. Okay, if it's easier for you, you can forget the technique of boxing it, moving it to the opposite side. If you want to stick to plus 7, cross out, that's fine. Okay, so now we have 3u is less than or equal to 21. We are not done yet, because we still have that 3 to contend with. We divide by 3 on both sides. That allows us to get rid of that 3. And we now have u is less than or equal to 7. We divided by positive 3, not negative 3. Therefore, we did not flip the sign. Okay, so we solved it because we isolated the variable. Now we got to graph it. Okay, notice, you only have one variable here. That's why it's on a number line type of graph. All right, when we graph on the coordinate plane like that, we have an equation that looks like this. There's two variables here. That's why you have an xy axis. Here, there's only one variable. So they just give you one of the axes, namely the number line. Okay. How do we handle this? Well, we go to the number in question, which is 7. Right? Always put 0 down as a reference, and you can just indicate that that is positive 7. Because this is a less than or equal sign, we're going to make this circle circled in, and then we're going to shade all those areas where u is less than or equal to 7. Okay, if you're not sure, you can do this. Okay, put a little line here and put u on both sides of that 7. Okay, now follow the directions. You're either going to shade this way or you're going to shade that way. You put a u on both sides and you ask yourself, where does the u, the blue u, match this criteria? Where is u less than or equal to 7? Well, it's on this side. So you shade to the left. That's your answer for 17. Okay, let's do the next one. Okay, there's 2 ways to do these right here. You can either separate this into 2 equations, or you can work with what you have here. Now, if it's pretty simple here, I think it's easier to work with what you have here. Keep in mind, if you have to divide or multiply by negative, you got to flip the sign. So let's proceed. We have to isolate n. N has a neighbor, that 9 right there. We could subtract 9 here, but then we have to do it everywhere. This becomes 0. No need to flip the sign because we are subtracting 9. We are not dividing or multiplying. Now we have negative 1 minus 9. If we go to our number line, 0, we start at negative 1. In other words, we're trying to figure out what negative 1 minus 9 is. We start at negative 1, and then that minus sign tells us we're going left. We're going to go 9 units to the left and end up at negative 10. So this is going to be negative 10 over here. Now we have 17 minus 9 over here, and that's going to be 8. So our solution set n is going to be between 8 and negative 10. So we put an 8 here, positive. We put negative 10 down here. Because this is only a less than sign, no less than or equal sign, we're going to make this open circle, and we're going to shade the area in between. So this graph says the same thing as what we have here. This graph says that n is between 8 and negative 10. And there it is. Okay. Absolute value inequalities. Remember, absolute values pose some hurdles. The first hurdle when we're dealing with an absolute value equation is we want to get the construct that the absolute value is by itself. And before we said it was equal to something on the other side. But now these are inequalities. So now you're going to have greater than or equal to something else. They already gave us that. See how this is by itself? Okay, so now we go to part 2. In dealing with absolute values, we take the stuff and we just repeat what we have, and that is one part of the problem. We create a big line in between, and we have a second problem unrelated to this, where we're going to set the stuff and we're going to multiply the opposite side by negative 1. But guess what? Because we multiply the opposite side by negative 1, we have to flip that sign. All right, if you need to, just go back and rewind the video and watch that again. We have our absolute value by itself. we create two scenarios. Scenario one is we set the stuff inside the absolute value and we just repeat exactly what we have. Scenario two, we put the stuff from the inside the absolute value, we multiply the opposite side by -1, and because this is inequality, we have to flip the sign. Now we solve these separately. We're going to add 7 to both sides. We're going to have h is greater than or equal to 12. Over here, we're going to have h minus 7 is less than or equal to -5. We're going to add 7 to both sides. And we're going to get h is less than or equal to 2. We are now going to check our answers. If we plug in 12 here, we get the absolute value of 12 minus 7 is greater than or equal to 5. Absolute value of 5 greater than or equal to 5. It is. It's equal to 5. So this solution is a good one. Now, h is less than or equal to 2. We're going to put 2 in here. 2 gives us 2 minus 7 is -5, excuse me. Absolute value of -5 is +5. 5 is greater than or equal to 5, so this solution works. Okay, now we're going to graph it. To graph, we go to the number in question. So I'm going to have +2 here. And I'm going to have +12 over here. Maybe I could separate those a little bit more. Again, folks, you don't have to have these perfect. In other words, you don't have to have 10 tick marks between these two. As long as you designate that this is +2 and +12. Okay, you want to circle both of those in completely because they're both less than or equal to signs. Okay, let's do the first one. You put h on both sides. We're going to do this guy right here. You put h on both sides of that line, and you read this out loud to yourself. Where is h less than or equal to 2? It's this one. So you shade this side. Next, okay, so we erase that. Next, you put a line here, you put h on both sides. You look at what this is saying. H is greater than or equal to 12. Which of these h's is greater than 12? It's this one. So you shade over here. And that is your final answer. Okay, let's do one more of these because they're tricky. Here we go. We have an absolute value problem. In absolute value problems, we get the absolute value on its own. That's our first step. They did that for us. Okay, if they had put a 3 here, for example, we can't progress until we divide both sides by 3 to get rid of that 3. But we don't have that here. We had that previously. Here, we have the absolute value box by itself. Next move, we create 2 different scenarios. First, we take the stuff inside and we set it to exactly what we see. That's scenario number 1. Scenario number 2, we put a line here indicating it's totally different. We take the stuff, we multiply the opposite side by -1, and we do that. When we do that, we have to flip the sign. Anytime you multiply or divide and you have an inequality, you have to flip the sign. So we're going to flip the sign, and -7 times -1 is going to be +7. These are the two problems we need to solve. So let's do it. On the left side, we're going to add 12 to both sides. Now we're going to divide by 4. On the right side, we're going to add 12 to both sides. We're going to divide by 4. And these are our two solutions. Okay, let's go ahead and graph them. Okay, now, as I'm getting ready to graph this, what do I see? Look at the intuition here of this problem. We have something in absolute value being greater than a negative number. That means this is going to be all solutions. Because no matter what you put in here, it's going to be greater than -7. Even if you end up with 0, 0 is greater than -7. But let's go through the exercise of graphing. Okay. Sometimes I find it helpful to put things in decimal form rather than in fraction form when I'm graphing. So if I want to put this in decimal form, I would do this. The 5 drops inside the box, and I put a decimal 0, 0. And then I would ask myself, I'm doing long division. How many times does 4 go into 5? The answer is 1. 1 times 4 is 4. Bring down the 0. Bring that decimal place up top. How many times does 4 go into 10? 2. 2 times 4 is 8. Bring down that 0, and I get 1.25. To me, it's a little easier to graph 1.25 than 5/4, but they have the same value. Okay, I do that a lot in math. Okay, so now we have x is greater than 1.25. And we're going to do the same thing here with the 19 over 4. I'm going to change that to a decimal to make my life easier. I can visualize it better. Okay, so the 19 drops in, and I add 2 zeros. Okay. How many times does 4 go into 1? We can't. 4 goes into 19 4 times. 4 times 4 is 16. 3, bring down the 0. Don't forget that decimal place goes straight up. How many times does 4 go into 30? 7 times. 7 times 4 is 28. Subtract, you get 2, bring down the 0, you get 20. How many times does 4 go into 20? 5. So we have x is greater than 1.25, and we have x is less than 4.75. Okay, now let's go ahead and graph that. Okay. On a number line, whatever's greater is to the right. So let's start there. Let's call this 4.75. We're going to put our line there, and we're going to put x's on both sides. And then we're going to follow what this is telling us. This is telling us to shade. Oh, and by the way, this is now an open circle right now. It's an open circle. This is telling us we want to choose the x that is less than 4.75. Which of these two x's is less than 4.75? It's this one. Therefore, we're going to shade everything to the left here. All the way down. All the way down to negative infinity. Let's do the other one now. Here, we're going to call this 1.25. You want to put an open circle here, but the fact that this shades everything means that that's going to be included. All right, so I'll put a circle here, but I'm going to leave it closed in. Not because that's of that symbol, but because this shading dictates that all of this is shaded. I'm going to put my line. I'm going to put x on both sides of that line. And I'm going to follow these rules. Which of these x's is greater than 1.25? It's this one. Here's 1.25. This tells me they want me to shade x greater than 1.25. It's one of these two. It's going to be this one because it's to the right. That means I'm going to shade all of this, including that open circle, all the way up to infinity. That means everything is shaded. So this has infinite solutions. And again, we predicted that from the beginning because we knew that anything that emerged from here has got to be greater than a negative number. So if you're on your test and you see absolute value greater than a negative number, immediately it's infinite solutions. Okay, let's end here.